Section 1.4 looks at solving one- and two-step equations. So before we can start solving equations, we're going to talk about inverse operations. These are going to be the tools that we use to solve equations. So an inverse means it undoes what's being done in the one operation. Operations, I'm talking about our four main operations of adding, subtracting, multiplying, and dividing, but we're also going to touch on a few other operations we can do when we're solving equations. The first one, obviously, if we're talking about addition, the inverse, if I wanted to undo, I accidentally add something on my calculator, in order to undo it, I would just subtract that same number, and it goes both ways. So if I accidentally subtracted a number, I would just add it back and be where I was before. So addition and subtraction are inverse operations of each other. So the next one, multiplication. If I'm multiplying something, I use an X or a little dot, or a little dot, or I just put them next to each other. If I wanted to undo multiplying something, I would divide it. So if I wanted to undo the division of something, I would multiply it by that same number. They're inverse operations of each other. And here's that other one. Those were our basic four. Here's another one. Something was squared, so x squared. I would undo that by taking the square root. I would not divide it by 2. I take the square root and it looks like this. If you haven't seen that before, that's fine. We're going to touch on that later. But if I had taken the square root, in order to get rid of that square root, I would square. They're inverse operations of each other. So also before we get started, I just want to touch on things that you've seen before, probably just being aware of what things can look like when they look a little differently, but they're things you've seen before. So same value, same expressions, operations, but just a different appearance. So this first one here, 3 plus x, make sure you recognize that this is really addition. I could rewrite this as x plus 3. When we're talking about the middle one, recognizing subtraction, if I have a -4 plus something, or a negative number plus something, this is really y minus 4. Recognize that that is subtraction. Excuse me. And then the last one, 5a, recognizing that when a number is right next to a variable, this is multiplication. This is the same thing as 5 times a. I would multiply whatever I'm plugging in for a there, whatever I'm evaluating at a, I'd plug that in there and multiply those two together. Okay, when we're solving, we're going to have 3 different options, basically, or outcomes that we're looking for. And the first one is there's one solution to our equation. That's probably the most common one. Okay, so there's one number that's going to make it work. So in this case, I have one number that's going to make this work. If I'm saying what plus 5 gives me 13, I have a 5 block here and then an x block, and it's weighted the same as a 13 block, I would know, oh, x is equal to 8. Think of an equation as a scale, and it needs to be perfectly balanced. So I couldn't plug in that x here was 10, or this side would be 15, and this side would be 13, which would mean if I had 15 here, the scale would be up, the 13 would be way less. So think of that. You're always trying to keep that balance. So whatever you're doing to one side, you need to do the other so that everything stays balanced. You don't want any lopsided scales. All right, this middle one where there's no solution, you're going to end up with an equation, something at the end where you end up with a false statement. So here, if I took both of those, well, above they use 3 and 5, but if I took both of those x's off, if these x's up on this scale are the exact same thing, there's no way this scale would really look like that. It would actually look like this. There would be a 3 up here and a 5 down here because they're not equal. 3 is not equal to 5. In the purple example, 3 is not equal to -7. There's no x value I can plug in there. There's no 2 of the exact same blocks I can put on this scale that will magically make it become a straight scale. It will magically make it become balanced, right? It's not going to happen. There's no way I could make it become like this, right? They're the same block, it's always going to be off because 5 is the one that weighs more. Okay, so there's no solution. It's going to happen. You end up with 2 constants, so 2 things without variables. They're not the same number. It's not a true statement. The opposite of that would be that there are infinite solutions. So no matter what number you plug in there, it's always going to work. So if I have a 4 and a 4, I could put a block that weighs 100 on this side and a block that weighs 100 on this side, and I would still have 104 and 104. Okay, so this would be where our x's cancel out, and I'm left with a true solution. That ends up being true. So for this example, you would, I'm going to make a note on here, a false statement at the end. And this one you'd be left with a true statement. So here you would write, this one would be no solution. And this one you could write all reals or infinite solutions. So those are our three outcomes. We're either going to have one solution, no solution, nothing will ever make that scale balance. This picture right here is pretty deceiving the way they have it level, and it really shouldn't be. And then the last one is an infinite solution, infinite number of solutions, meaning every single number will work. Okay, let's look at some examples. So here's how we're going to do this when we're solving equations. We're going to start by this, think of this as our balance in a scale, right? When you have a scale, you have one plate over here, one plate over here, this pedestal in the middle, right? Think of the equal sign as that pedestal. Whatever you put on this side, it's going to make this side go down unless you put the same thing on this side, in which case it'll wobble a little bit and then it'll balance itself out. So that's what we want to do. I draw a line down the equal sign. Now I have to isolate the variable, so that's my goal. Okay, so I'm going to make a note up here. The goal when I'm solving these is to isolate the variable. So isolate means get alone, and the variable meaning the letter. Okay, I also have to follow the rules of math though. I can't just pick pieces up and move them around however I want. So look at this example, 26 equals 8 plus v. You might be thinking in your head, well, what would I add to 8 to get to 26? You could do it without rearranging if you have good mental math. However, there's going to be situations where you're going to need to be doing a lot more steps to get to your final answer, so you need to show your work. You must show work. So here's what I'm going to do. This is my variable. I'm going to try and isolate it. So what I'm going to do is I need to get rid of this 8. I look, right now, remember we said, recognize that this is addition. So the inverse operation of addition is subtraction. So in order to keep this scale balanced, if I take 8 pieces off of this side, I also need to take 8 pieces off of this side. When I do to one side, I must do to the other. So when I do that here, 8 minus 8, this goes away to 0. It cancels itself out. That's what I wanted. That's what an inverse operation does. And I'm just left with v on that side. Over here, 26 minus 8 is going to leave me with 18. So in this case, my answer, v is equal to 18. And I could always go back and check and say, if I plug 18, evaluate this at 18, take 18 and plug it in, 8 plus 18 leaves me with 26. It checks out, my answer is correct. Okay, there's quite a few examples like that one. I'm going to skip to a little more challenging one where we're going to be doing some, let's do some multiplication and then we'll do some division. So 14, I have 10n equals 40. We said this, to be aware of this, when the number and the coefficient are attached, the coefficient and the variable are attached, we're talking multiplication. So I need to get rid of this times 10 on the left side. First thing I need to do, draw a line down my equal sign so I know what I'm talking about when I say working on both sides of the equation. If I'm multiplying by 10, my inverse operation is going to be division. So I'm going to divide by 10 on both sides. 10 divided by 10 leaves me with 1n, and 40 divided by 10 leaves me with 4. I don't really need that 1n because if I'm writing that there's an n, I know it has to be 1. So I have n is equal to 4. However, it's not wrong to write the 1. You won't lose points or anything like that. Just know that 1n is the same as n. So in this case, my answer is 4. If I hop over here to number 13, I have negative 6 is equal to b divided by 18. I'm going to start by drawing a line down the middle, and I need to say what operation is happening here that I need to undo, what inverse I need to look at. Well, the b is being divided by 18, so the opposite would be multiplying by 18. So I multiply both sides by 18, over here, divide and multiply, if I'm talking about fractions, one in the top, one in the bottom, I can reduce. B is equal to, I show my work, 18 times 6 leaves me with, whoop, 8 times 6 gives me 48. I carry the 4. 6 times 1 is 6, plus 4 gives me 108. So B is equal to 108. Sorry, this B looks kind of like a 6. So let's do this. So my answer here, B is equal to 108. Okay, I'm going to hop down to somewhere we get into two-step equations where I have to do, notice we're only doing one operation in these examples before we're moving things in order to get to our final answer, right? All I had to do here was multiply. All I had to do here was divide. There's going to be ones where we have to do multiple operations before we can isolate our variable. So I'm going to look at number 1. It says 6 is equal to a divided by 4 plus 2. So my goal is to isolate this variable. First thing I do, draw a line down my equal sign. Instead of doing order of operations, PEMDAS, and doing the multiplication and division first, I have to work backwards here. So I'm going to start with the addition or subtraction first, and then go to my multiplication or division. So the first thing I want to do is I want to get rid of this 2 right here. Since I was adding the 2, I'm going to subtract the 2 on both sides. That's my inverse operation. And what happens here is the 2's cancel out. So I have a divided by 4 is equal to 6 minus 2 leaves me with 4. Still trying to isolate this variable. So right now I'm multiplying by 4. I'm sorry, I'm dividing by 4, so I'm going to multiply it by 4. Multiply by 4 on both sides to keep everything balanced, and I end up with a is equal to 16. I could check this by saying 6 is equal to, I'm going to find out, 16 divided by 4 plus 2. And I would follow PEMDAS here. So 16 divided by 4 is 4 plus 2 is equal to 6. 6 is equal to 6. This checks out. Since I have one number that made this equation true, is my equation have one solution, no solution, or infinite solutions? Since 16 is the only number that's going to work here, I have one solution, one unique solution in this case. I'm going to do one more example and then let you guys figure things out for yourself. Here we go. We have number 3, 9x minus 7 equals negative 7. I'm trying to isolate my variable, which is the x. Start by drawing a line down my equal sign to come up with my sides of my equation. I realize this negative 7 here is really subtraction. So in order to get rid of that, I'm going to have to add 7 on both sides. I have to do the inverse operation. Negative 7 plus 7 is 0. If they don't cancel out, you did something wrong. So if you had subtracted 7, you would really have negative 14 there. So make sure they cancel out. I have 9x is equal to negative 7 plus 7 is 0. I'm going to divide by 9 on both sides. The inverse operation, the multiplying, is dividing. And I'm just left with x is equal to 0 divided by 9 is equal to 0. So my answer here, x is equal to 0. The best thing you can do for yourself is stay organized. Make sure you're showing your steps, showing your work, and really thinking, what is the opposite here? What's the inverse operation? And make sure that what you're doing to one side, you're doing to the other so your equation is staying balanced.